All right, here we go with dilations. Okay, we have A to A prime, C to C prime, and B to B prime. And you all have a ruler, so I want you to grab that ruler. And here's what I want you to do. I want you to start it, well, I want you to line up A and A prime. And I want you to use a dotted line. And I want you to kind of make a line like that. Very long line. And then I want you to do the same thing with C to C prime. So like that. And then you'll do it again for B to B prime. Okay, so when you're done, you'll have something that looks like this. Then I want you to find that intersection of those three lines and put a dot there. Okay. So this ABC, that is my pre-image. And the A prime, B prime, C prime is my image. In other words, that's the new one. And this dot right here is the center of dilation. Not dilation, but dilation. Okay? Here's a little tip. When the image is between the pre-image and the center of dilation, you have a reduction. If this had been the original and this one had been the new one, it would have been an enlargement. Okay? So just a little observation. All right? You see how we can map these? They are the same shape. They are in the same orientation. I can map points on the points, but they are not the same size. These are similar triangles. They are not congruent. So let's go ahead and write that down. Triangles are similar, comma, not congruent. Dilations are not a rigid transformation. A rigid transformation, which is what you have with translations, reflections, and rotations. Rigid means the size does not change. Dilations are not rigid. Their size changes. So they're no longer congruent. Okay? That'll be the difference between what we've already done and what we're doing today. All right, so here we go. Dilations are the enlargement or reduction of a figure. You make it bigger, you make it smaller. We use a scale factor to do that. The scale factor indicates how much the figure will enlarge or reduce. In other words, maybe we double the size. Anyone ever made bread? You know how you like put the dough in the bowl and you cover it and you let it double in size? You let it rise? That's an enlargement. Okay? Maybe you want half the size. Okay? Maybe you shrink it. Anybody ever taken a balloon And you like undid it and then you like took out some of the air so it was smaller? Yeah. Okay. I'm not talking about the helium with the squeaky voice. I'm talking about making the balloon bigger or smaller. Okay. So we're going to use a variable for scale factor and we're going to use the letter K. K for constant. It's a hard K sound. They use a K. I know constant starts with a C. K for constant. Okay, so when K is bigger than 1, it is an enlargement. Okay, so if K is a 2, I doubled it. If K is a 3, I've tripled it. When K is bigger than 0, but smaller than 1, so look at how I wrote that. K is in the middle of 0 and 1. It's bigger than 0, it's smaller than 1. In other words, it's a fraction. Okay, the dilation is a reduction. Somebody tell me, what do you think about when K is equal to 1? What do you think about that? If K is bigger than 1, we made it bigger. If K is less than 1, we made it smaller. Well, what if K is exactly 1? Doesn't change size. I want you to look at your paper, and I want you to look at your neighbor's paper. Are they the same size? It's because I went to the copier. I didn't shrink it or enlarge it. I just copied it, right? So K equals 1 is an exact copy. In other words, it would be congruent. Okay? An enlargement or reduction creates similar figures. And when K is 1, it is congruent figures. Can K ever be 0? Why can K not be 0? Think about it. If you multiply by 0, what do you get? 0. Okay? So if it's 1, it's an exact copy. If it's bigger than 1, it's bigger. If it's smaller than 1, it's smaller. But if it's 0, then I have literally just vaporized it and it's gone away. That doesn't work. Okay? So we can't have K as 0. That center of dilation here is where everything basically originates from. All right? Kind of like our sun, right? And our sun will cast shadows on things. Have you ever noticed that your shadow is actually bigger than yourself? Yeah. It's taller, it's longer than you are tall, right? Okay? So you can think of your center of dilation like the sun. You can think of the image as a shadow. The pre-image is the original item. And you see these lines that I drew to map everything? Those are like sun rays. Right? Does that make sense? You can visualize that, right? In your head? Okay. Let's do number 1 and number 4. Number 1 is a K equals 2. Number 4 is a K equals 1/4. K equals 2. Does that mean our image is going to be bigger or smaller? Bigger. Okay, so this is going to be an enlargement. Okay, let's go ahead and, like, what does 2 mean? It means that it doubled, right? Our enlargement is double the size. Okay, so let's go graph that. -5, 1. This is a 10 by 10 grid. -5, comma 1. This is R. And then I have negative 3 comma 4. This is S, and T is 2, negative 1. Okay. And then I can draw my little triangle. You can just draw it like we did before. You can use your ruler if you want to. Okay, so there's that. Now, our scale factor is 2. Here's the fun part. Every single number that you see, you are going to multiply it by 2. So instead of negative 5 comma 1, I would have negative 10 comma 2. Negative 3 4 becomes negative 6 8, and 2 negative 1 becomes 4 negative 2. So those new ordered pairs are my new shape. So these are all bigger. So let's go graph that. I need negative 10, 2, so over here, that will be R prime. Then we have negative 6, 8. So let's see, that would be here and here. That would be S prime. And T is 4, negative 2. That would be T prime. And then I'm going to draw our new shape. And then I'm going to show you something really cool. The center of our dilation is 0, 0. That's actually your default. The center is 0, 0. Unless you're told otherwise. There are times where it is not 0, 0. But the default is 0, 0. So I want to just show you something that I think is really cool. Ready? If I go from 0, 0, and I'm going to do rise and run, I want to get to S. So 1, 2, 3, 4 up, and then I go 3 over. Do I get to S? When I do that, do I get to S? Where did I end up? Guys, if I start here and I go up 4 and over 3, where did I end up? At S. Okay, thanks. Now, that was an up 4 over 3. I want you to do it again from here. Up 4 and over 3. Where did you end up? S prime. This is 1 time. This is 2 times. And what's your scale factor? 2. Okay, do y'all see that? Okay, now, the very long way to do this would be to also verify distance 6 times. 3 distances for the small triangle, 3 distances for the large triangle, and make sure that all of the distances are double. That's a lot of extra work that we're not going to do. Okay? All right, let's go down to number 4. Now we have K is equal to 1/4. Is that an enlargement or reduction? Very nice. Reduction. Okay. That means, this one means it is 4 times smaller. Okay? It's 1/4 of the size that it was. So what we're going to do is we're going to go ahead and graph that. So we have negative 4, 8. That is W. X is 10, comma 0. That's over here. And Y is negative 2, negative 8. Okay, and then we can just draw our triangle. It's quite big. Takes up almost the whole graph. Okay, so there's our original. And we're going to make this 4 times smaller. We're going to lose 75% of our size. We're going to only keep that 25%. Don't forget that your center is 0, 0, unless you're told otherwise. So what I'm going to do is I'm going to take every single number and I'm going to multiply by 1/4. Okay? 1/4 of -4 is a -1, and 1/4 of 8 is 2. 1/4 of 10, 2.5. 1/4 of 0 is 0. 1/4 of -2 is a -5/10. And then 1/4 of -8 is -2. Okay, those are our new ordered pairs. So let's go graph those. So I have -1, 2. This is W prime. I have 2.5, 0. So I go 1, 2.5 right there. And that's X prime. And then I have -5/10, -1/2, and then -2. So like right there. Everybody see that? Go to the left, half, and go down 2. And then you have your new one. I know. Now, I want to remind you of something I said earlier. When the new image is in between the center and the original image, it is a reduction. Right? That pink one is in between that center and the image, or the pre-image. Here, I have my center, and then I have my pre-image, and then I have my image on the outside. That's an enlargement. If you were to take your pencil and draw lines to go in between your points like you did earlier, they should all meet at 0, 0. Okay, so X to X prime, Y to Y prime, W to W prime. And when you do that, see how all of them converge on 0, 0? Okay, so I know I have it graphed correctly. That's something I like to check, because you know sometimes I get in a hurry and I put it in the wrong spot, right? Okay, that's the basics. Now we're going to come over here, this next page. And I want you to change that to a 2. Okay. Just so you know, that dot is 0, 0 on our graph. This dot is 0, 0 on our graph. Okay. So this is going to be a little exercise on, if I'm asked to find the center, how do I do that? Now, unless you're told otherwise, remember I said that the default is always the center is 0, 0. Okay, but sometimes it's not. So what we're going to do is we're going to verify if it is 0, 0. Okay, if it is, great. If it isn't, well, that's okay too. So here's what I'm going to do. This right here, from here to here, is how much? 1, 2, 3, 4, 5, 6, 7. Right? Is that true? And this is 4. And then I could find distance and get those. But I don't want to do all that. That's a lot of work. So A is 7 comma 0, or sorry, 0 comma 7. And then we need B and C. 1, 2, 3, 4. So B is 4 comma 3. B.
Oh, okay. Got it.
And then C is 4 comma negative 1. Okay, so your scale factor is 1/4. Every single number gets multiplied by 1/4. So we're going to have A prime, B prime, and C prime. Oop, not double prime. Well, 1/4 of 0 is 0. And then what is 7 divided by 4? Or 7 times 1/4? Or 7 over 4? Well, we want 1.75. We need to be really accurate when we're graphing. And then 1/4 of 4 is a 1. 3 divided by 4, that's your 75/100ths, your 0.75. And then 4 divided by 4 is 1 again. And negative 1, 1/4 of that is a negative, is that 25/100ths, 0.25. Okay, those are our new points. All right, so we're going to go find A. Here's 0. We're going to go find 1. And we're going to find 1.5. And then we're going to go a little bit further for 1.75. And this is A prime. Okay, and then we're going to have 1. And then we're going to have 0.75. That's going to be B prime. And then we're going to have 1, and we're going to go down about 1/4. That'll be C prime. And that is our new triangle. Okay. And then to make sure that we drew it right, we're going to quote, find the center by drawing those lines. This is something you need to practice. B to B prime. And A to A prime. That's pretty. And C to C prime. Okay. Now I have just verified that my center is 0, 0. Okay. My center is 0, 0. We could do the same thing over here. All right. I think we don't need to. I think doing that once is enough. Let's go. These are kind of all the same. So let's go to the next page. Okay. Let's go to the next page. All right, so some of this is going to kind of be a recap of what we've already done, and some of it will be some extra information. All right, a dilation is a transformation that can change the size. Okay, changes the size, but leaves the shape unchanged. Again, similar figures. Okay, now it has a center of dilation and a scale factor. We just talked about that. Okay, that's going to determine the position and the size after the dilation. Now, we're going to ask you questions like this. We're going to give you two shapes, and we're going to say, what's the scale factor? And you're going to have to figure it out. So here's what you do. First of all, similar figures have same angle measurements. So right here, I am telling you that angle A and angle A prime are congruent, B and B prime are congruent. C and C prime are congruent. I'm telling you that. The next thing that I'm telling you are the size of the length of the sides. So we have 6 and 4 and 3. And then for this one, we have 3 and 2 and 1.5. Now, so far, when we have dealt with K, we have been multiplying. What is the opposite of multiplying? Dividing. So, from 6 to 3, 4 to 2, 3 to 1.5, you're getting smaller. Okay? In order to figure out what you're going to be multiplying by, you can divide, but you also want to think of it like this. 2 is how much of 4? It's 1/2. 3 is how much of 6? It's also 1/2. And 1.5 is how much of 3? 1/2. Guess what your scale factor is? 1/2. Another way to do that, because sometimes they're not that friendly. So another way to do that is to use this over here. Image divided by pre-image, or as I like to say, new divided by old. So if I did 3 divided by 6, what do I get? I get 1/2. And if I did 1.5 divided by 3, what do I get? And if I did 2 divided by 4, what do I get? 1/2. Okay, so I showed you this because for it to be a dilation, when you do that for all of the sides, you must have a constant scale factor. If any of these numbers were not 1/2, it would not be a dilation. It'd be something else. It'd be a stretch horizontally or a stretch vertically. So you've got to have them all the same. And that's because the length of the sides are proportional. Okay? Corresponding angles are congruent. I want you to write that down. Angles are congruent. Sides are proportional. Okay, the corresponding sides, the corresponding angles. Okay, dilations also do something else. They preserve several things of your shapes. First of all, they preserve the angle measurements. You're going to have congruent angles. They're going to preserve what we call betweenness. And here's what that means. If I have a point, let's say up here, I have E. Over here, I have E prime. It stayed in between A and B. It didn't jump to another side. Okay? So E was between A and B, and E prime is still between A prime and B prime. It didn't jump to a different leg. Collinearity. A and B are collinear. A and C are collinear. Well, over here, A prime, B prime, collinear. A prime, C prime, collinear. It stays the same. And then finally, orientation. That is the direction in which it faces, how it sits. These are both facing that same direction. Okay? If any of these are a no, it is not a dilation. Okay? So if they're all yes, it is a dilation. if any are no, it is not a dilation. It only takes one no for it to not be a dilation. So let's take a look at this. This is a prime example. Here are these. Preserves angle measure, yes. And we could verify that with a protractor if we wanted to. Preserves betweenness, yes. This point right here is still between the same betweenness where they are on each leg. Okay, collinearity, yes. But look at it. On this side I have C prime, D prime, but over here I have C and D. Do you see how they kind of flip-flopped? That is not the same orientation. So because I have one no, just takes one, it is not a dilation. Huh? You're welcome. Okay, when you're ready, turn your paper over. We're just about done. Okay, so let's do this one together. This, by the way, is a classic test question. Maybe you star it. We love to ask this question. Okay, so right here, I'm telling you that all the angles are congruent, yes? Is that what this means? Sure. So the angle measures are preserved. Preserves betweenness. If I have this point right here and that point right there, okay, the same point, they're still between the A and the B part. Okay, AC and A prime, C prime, all the collinear points are still collinear. And it is in the same facing position. Okay, the C's are both at the top, the A's are both on the left, and the B's are both on the right. So this is a yes. So is this a dilation? Yes. Now we're going to figure out the scale factor. Okay, you see that? We're not going to do that. That is a, who wants to find the distance of all 6 sides? Anybody? Okay, we could find the distance of all 6 sides. I don't want to do that. Okay? But what we can do is a couple of things. How far is it from 0, 0 to C? How far is that? Okay. How far is it from 0, 0 to C prime? 4. Okay, so what do you think your scale factor is? Are we getting bigger or smaller? We're getting bigger, so what do you think your scale factor is? I'm going from a 2 to a 4. I'm going from a 2, this is 2, I'm going to 4. What's my scale factor? 2. Another way to check that is, let's take a look at A and A prime. A is -2, -2. What is A prime? -4, -4. How do you get from -2 to -4? No, we don't add for dilations. Guys, we haven't added at all. Multiply by what? Number times 2. What's your scale factor? 2. The reason why I showed you this is because if you have horizontal and vertical sides like lines, you can use those and just measure the length. If you don't, you only have diagonals, I would use the ordered pairs. So let's do this really fast. Okay, here's what I would do. You see CD and then C prime, D prime. Okay, so we're going to take C prime, D prime, and and we're going to divide it by CD. How tall is C prime D prime? How tall is that? How many boxes? 3. And for CD, how many boxes? 2. So what is that? What is 3 divided by 2? What is 3 divided by 2? Thank you. I knew you guys knew that. Okay, now look right here. We have DE, and then we have D prime to E prime, and E prime is not all the way at the corner. So, D prime, E prime, and then we have DE. How wide is D prime, E prime? How many boxes? 4.5, okay. How wide is DE? 3. What's 4.5 divided by 3? I think we need to start getting our calculators. Okay? Are they the same scale factor? Yeah. Is that a dilation? Yeah. So this is a yes. Okay, take a look at this. First of all, are they facing the same direction? So is this a dilation? Boom, done. You don't even have to even do any math. You can see here that this is 4 and that's 3, which is, you know, but they're not the same direction. So the answer is no. Okay? Yes? All right. I'm going to leave this one. Okay? But this is the end of our notes for today.